Good morning, good afternoon, or good evening, depending on where you are in the world. My name is Sharon Florentine. Welcome to today's DevOps.com webinar, Shifting Security Left, Streamlining Enterprise Secrets Management Workflows with Self-Service, brought to you by CyberArk and Red Hat OpenShift. We have an awesome webinar for you today, but before we get started, I need to go through some housekeeping items with you. First, please remember this event is being recorded, so if you miss any or all of it, you'll be able to go back and watch it again. We will send you an email with instructions for accessing the webinar on demand, or you can always visit us at devops.com/webinars. It will be there for you as well. We are taking questions throughout the presentation, so you can use the Q&A tab on your console to submit questions at any time. We will get to as many as possible at the end of the presentation, so go ahead and send them on in. Finally, we're doing a drawing for 4 $25 Amazon gift cards, so stick around until the end and see if you are a winner. All right, with that, I am pleased to introduce to you today Dave Muir. He's with Red Hat, the Global Solutions Architect for Security ISVs, and Jody Hunt with CyberArk Software. He is a DevSecOps SME. I'm going to turn my microphone off and my camera off and let you get right into it.
Thank you, Sharon, and welcome everybody. Excited to talk to you today about shifting security left and how we can streamline enterprise secrets with CyberArk and Red Hat OpenShift. I just wanted to take 10-15 minutes up front to talk about Red Hat and Red Hat's view on DevSecOps. And you're probably wondering, well, what does a Linux company have to do with DevSecOps? Well, interestingly enough, over the past several years, Red Hat has more products than Red Hat Enterprise Linux, which is also very much security in mind. But we have products like a Kubernetes, a certified Kubernetes distribution called Red Hat OpenShift, as well as things like Ansible. I'm sure you've all heard of a lot of the products that we have, but having those products allows us to work with great partners like CyberArk and get a really unique view or holistic view of an application development pipeline, for example, especially if you're thinking about DevOps and containers. Now, I do want to mention that DevSecOps and DevOps should be synonymous. Security should be part of DevOps as you're going through that journey, but we always like to use DevSecOps in my team just to put more focus on the security side of things, since I'm focused on our security ISVs. We want to make sure that security has a seat at the table within your transformation to DevOps. So really emphasizing, securing DevOps, because one of the things, if you think about traditional application deployment, I was a developer. One of the things that kind of slowed me down was security checks and some of the security loop things I had to go through to get my application deployed. And so ensuring that you have security baked in, automated, and throughout the DevOps lifecycle is a key piece. And achieving DevOps, which is all about faster deployments, as well as breaking down those silos, not only between dev and ops, but also between DevOps and security teams. And so you can see here in this slide that Red Hat has a vision around, Red Hat's open hybrid cloud technologies and how our partners like CyberArk enhance and extend that ecosystem by providing a comprehensive DevSecOps solution. Red Hat can help you, build secure applications as well as deploy those applications on secure infrastructure. But it's not only about the technical piece. Red Hat can also help customers through their journey of DevSecOps through process and culture. We've got consulting services, training, a global transformation office, innovation labs that help our customers through that journey. And so thinking about culture, one of the things, or handful of things to keep in mind are these type of items as you're thinking about transforming yourself to a DevOps journey. One is around training. Training not only for the entire group of folks, but training specifically around developers. Developers, as I was a developer in the past, didn't really know a lot about security. And a developer is not going to be a security expert, but helping that developer with security concepts and secure coding practices will go a long way in terms of speeding up your DevOps journey as well, or getting towards that DevOps journey. The other thing to note is risk focus. Risk focus means that you can't solve every single security issue that is presented to you in an application pipeline. There's going to be, just thinking about container scans, there's going to be hundreds of vulnerabilities that are reported. So ensuring that you focus on the appropriate severities is key, so that you don't sink a ton of time into trying to resolve the entire, boil the ocean, basically. And that goes to speed and accuracy balance. You want to be able to continue the speed of DevOps, but balance that with the right amount of accuracy. You don't have to be 100% accurate on scans or things like that as well. One big thing for DevOps is transparency. Transparency is also a key aspect in DevSecOps, where not only the operations team provides transparency of what's going on in production with development teams, but things like providing tools to developers, or developers being transparent to the security and operations team. So it goes all three ways to eliminate those silos, promote that collaboration and teamwork. Another big thing is shared goals. So for example, having some DevOps or DevSecOps specific goals shared between operations, security, and developers are key. One that's very popular is time to fix security issues. If you think about DevOps and being able to deploy quicker, time to fix security issues in production should go down versus a traditional type of development lifecycle or software development. Another important one is percentage of deployments stopped due to failing security test. So if you think about traditional development again, a lot of times a developer will throw their app over the wall, but then, a day or so later, they'll get a spreadsheet from security saying your application has these vulnerabilities, you have to fix it. So being able to limit those amount of failed deployments through integrating security within DevOps and having developers understand security concepts and getting security tools in their hands in the IDE will go a long way into lowering that percentage of deployments failed. Of course, automating security at every point in the life cycle is key for DevSecOps to be successful. And then the other thing to note is security expertise. So I know some companies don't have enough security resources to have a security representative on each DevOps team or each application team, but maybe having a security champion in a team, or doing things like lunch and learns just to help to keep the security expertise and the knowledge flowing throughout all those three teams are key. So there's some of the culture items to think about as you're going through DevOps. Now, in terms of the technology, one of the things that Red Hat has done over the past year and a half is worked with the industry and our partners, especially around technologies and OpenShift, to come up with a taxonomy or a framework, as we call it, for DevSecOps. And this framework helps our customers, helps our partners consume security a little bit easier within their journey towards DevSecOps. There are so many different tools. There's so many different security methods, especially if you're coming from a legacy type of development practice. A lot of things have changed and a lot of things are different. So we have first categorized 9 different DevSecOps frameworks categories. You can see some of those 9 here. They continue to evolve as technologies evolve and DevOps matures. For example, application analysis, the one that you see there, we've recently been talking about changing that to something like vulnerability and config management, because it's not just application, it's also about the image, the container image that you want to analyze and find vulnerabilities for. And it's also about the configurations that are now, if you've heard about infrastructure of code or everything as code, that need to be looked at early on in the life cycle as well, which kind of see the 9 different categories there. Identity and access, compliance, very important in government and federal industries, network controls, data controls like data encryption and protection, runtime analysis and protection, audit and monitoring and remediation, and all that, again, will sit on platform security. And within these 9 categories, there's actually 34 different methods that we have identified. I won't go into each method, but for example, I mentioned like configuration management and application analysis. There's some app analysis type of features or functions there, like static analysis or software composition analysis. And you can go through all those methods to see, which ones might be interesting to you or not. But what we can do from here is actually take those methods and work with our partners to say, well, which partners fulfill certain methods in this framework. And that can then lay out a vision of a comprehensive DevSecOps solution where you've got Red Hat as the platform, like OpenShift, where OpenShift is a certified Kubernetes, but built with a lot of security in mind. So for example, it's built on top of Red Hat Enterprise Linux that by default has SE Linux on. OpenShift by default has RBAC turned on, where if you just used Kubernetes, upstream vanilla Kubernetes, you'd have to actually turn that on manually. And so Red Hat's the platform, and then our partners extend and enhance Red Hat to secure that entire DevOps lifecycle. Now we could take that a little bit step further and map out a pipeline like you see here, where you got your source code on the left, you go to an image and all the way to a running container. And those are some of the typical tools. Obviously, it might not be that simple in a complex enterprise, but overall, you've got an IDE, a source code management tool, build automation like Jenkins or Tekton, binary repository, container repository, and then you've got container orchestration and then cluster. And for each of those, we can then say, well, which security method maps to each of these different tools? Now, this is not to say, hey, you need to implement every single security method at every single integration point. No, this is really just a conversation starter to say, you should start thinking about doing this if you don't have this coverage either earlier or later on in the life cycle. At Red Hat, we always say defense in depth. So it probably would do no harm if you actually did multiple integration points of the same, security method in different integration points. But this framework here is to kind of guide you through that process. And then we can take this and with our partners map what our partners do alongside what Red Hat does. And this really becomes the start of a solution design for our customers to implement DevSecOps from a technical perspective. And you can see here's the CyberArk and Red Hat DevSecOps solution, where Red Hat takes care of things like runtime analysis on the right-hand side, or obviously the platform security, a lot of the network controls and compliance aspects. And then CyberArk will take care of your secrets management. You need secrets management in every single step of a DevSecOps pipeline. So that's why they're very key and very complementary to what Red Hat does. All right, I think actually that does it for me. So let me just make sure. Yeah, so I'm going to pass it over to Jody to take you through the CyberArk stuff.
Seems like maybe Jody got disconnected there for a second.
All righty. It looks like he's rejoining now. So as
Excellent.
he is rejoining, I will remind folks to please use the Q&A section to send any sort of questions that you have on what I just said or what Jody's about to say about secrets management. I could probably run through his slides, but I know I wouldn't do it justice. So looking forward to him rejoining. I would just say, oh,
sorry, I think I'm back now.
You are. Hey, welcome
all right.
back.
Sorry, network glitch. I don't know what happened. You started chopping up there right as you were getting to me. So hopefully that won't happen again.
No worries. I think you're on.
All righty.
Getting annoyed at my my slow playing here, so I'll let you go.
All right, very good. So the every good security presentation starts with just some fear factor stuff, and I think a lot of people had a lot of time on their hands in the past year with COVID because a lot of the cybercrime numbers we saw a big jump in. The estimated total cost of cybercrime jumped, 400% increase in overall attacks. We saw some novel new things like supply chain attacks. So the SolarWinds breach was one of the earliest, or certainly the most publicized aspect of or example of what is becoming more common, and that is where the actual supply chain is being attacked, where malware is being injected into the software development lifecycle. And this is just underscores everything that Dave has already said about the need to integrate security into your DevOps practices, make it truly DevSecOps. So the SolarWinds breach really started, as we said, in the supply chain, and then it was sort of classic. It laid in wait, started calling home, and then found ways to escalate privilege. So it's just a different vector, and this is yet another thing to be aware of. Is now how are your often very privileged CI/CD tools being secured, and that's really what CyberArk is focused on, along with human privilege. One of the things we like to say, that I say a lot anyway, is that privilege starts with people. Your developers are very privileged users in your network, and in many cases, they're building processes that delegate their privilege and in effect act on their behalf as system administrators to provision infrastructure, configure infrastructure, deploy applications, do all the things that a person would do, but it's not a person anymore. And so many people use Active Directory service accounts for those identities, but those have very limited controls around them. And so a lot of what we're about is adding those controls back in, integrating security into the development workflow, making it as transparent as possible, because you don't want to either make developers' life miserable or just make them hate coming to work. And especially you don't want to hinder their productivity. They're delivering value to the business. We don't want security to get in the way of that, but security is part of that value, part of the value of the deliverables that they're producing. And so this is some kind of a bit of a repetition of some of the framework that Dave was covering, but this is in just a different type of framework, the NIST 853 controls around access, audit, accountability, and identification and authentication. And these are the things that we'll focus on in the demo and really what we're looking for in terms of access in general, but in particular, access for applications. Because what we see today, almost every organization that we talk to, credentials are being stored in the places of most convenience, for lack of a better term. So if you're using Jenkins has a place to store credentials. Artifactory has a place to store secrets. Ansible Tower has a place to store credentials, but Ansible Tower also has an integration with CyberArk to dynamically retrieve those secrets on demand, so that the credentials aren't stored as in the Ansible Tower credential store. They're stored in the vault and retrieved on demand. And that's really kind of where we want to get every application, whether it's a CI/CD tool or a deployed app that's doing some kind of web service. The challenge is that the number of non-human identities are first not understood. In other words, we've not come across an organization that really has a good count or inventory of the non-human identities working in their network today. The bigger challenge is that the bottom of that iceberg is growing fast. And in part, that's because automation is being used more and more to deal with the complexity of the environments that you see today. So that the top of the iceberg isn't growing so much. The bottom of the and is more or less under control. Many people have good controls and understandings and governance around their human identities. The non-human identities, that we see this as a real growth opportunity for us, but it's also a risk that every organization has. So if we look at the reason for that, the problem is everybody's just very busy. Nobody has enough time to really focus on these things and do that manually. So automation is absolutely critical for dealing with this. And when we start talking about project teams and the developer experience, what we really want is to bring automation to bear to deliver on a good developer experience. Because if we look at what's involved here, it is extremely complex to know, okay, the developer has filled out a request for access to an environment. Which environment is it? You know, which cluster in OpenShift? Which namespace? What is the service account that the application is running as? All of these things need to be known for the identity. And then what does it really need access to? You know, what database, and should it even be granted access to this database? So a lot of the approval cycles that you see, classic approval cycles that you see in change management, need to be accelerated because we had one customer that looked at the number of requests that they could predict. It would take them, even if each request only took 5 minutes to approve and review and approve, it would take them 5 years to get to their backlog. So we need something that's autonomous. We want to empower users with as much autonomy as is feasible. So the key to scale is delegation and automation. But obviously that has to be done in the framework of controls where we're not delegating too much authority. And so to be efficient, we want something that's automated, that's self-service, that's secure, scalable, expeditious, low maintenance, but still all of this within the confines of our security objectives. So what that amounts to is we really need to start understanding who's responsible, what is the approval process for an application that needs access to a database, for example. What roles need to be responsible for creating the account in the database if it doesn't exist, and how does that happen? How does that get requested? Who creates the identity? Is it the security team that creates the identity and gives it permissions on the resource, or can we delegate that to the project team? And then, of course, who actually grants those permissions? So we'll step through this somewhat in a demo here in a bit. But this starts to get the challenge that vendors like Red Hat and CyberArk have is every customer is a little bit different. So every customer has different policies, different levels of scale that they need to support. And so often cases it is system integrators that are really delivering this solution, the overarching workflows that govern approvals and provisioning. But this is something that we have delivered for our customers. So this is an example. I won't go into it in great detail, but there's auto-approved and manually approved processes that can be fulfilled through a Jenkins workflow that ultimately give access to secrets in our Conjur Secrets Manager for an application. And so this is what I'm going to be stepping through here in just a minute. So this is something that we're becoming very familiar in helping organizations first understand. Second, give them a framework in which to start taking inventory of their applications, understanding what the risk factors are for their applications. But in general, the workflow for provisioning access for an app, for a project, starts with that request. Typically, this is coming in through a ticket through something like ServiceNow. Minimally, it says, here's this project, here's our project information, might have a billing code, who's the administrator that for that project to whom we can delegate some levels of responsibility. What's safe? So in CyberArk, our vault is composed of one or more safes. Typically, each project has its own safe and may need access to other safes as part of its work. So a safe contains accounts, and each account is a username and password for a database or an SSH key for a server. So each account, you can group related accounts together in a safe, and then you can control access to the safe and thereby control access to those resources. So in general, what we're saying is an access request is this application identity needs access to this safe in order to get access to the accounts, and they're in the databases or servers or whatever it is those accounts give access to. That access request needs to get approved. In some cases, that can be auto-approved. It needs to be processed, and in many cases, that's where automation really shines, is in the processing of that access request. And then the request needs to be communicated back to the project. But one thing we think is extremely important here now, getting back to that iceberg slide, is in the process of fulfilling these requests, we can start capturing those governance and GRC controls for actually governing application access. So we can review access after it's been provided. That can be provided to auditors and used to say, is this appropriate access or not? So we'll see a bit of that in the demo as well. What we're really getting at here is this is not something that can just simply be the responsibility of the security organization. As Dave was saying early on, and as DevOps has always been, it's about collaboration. Originally, it was, how do we accelerate the rate of change reliably into production? How do we eliminate application outages in production due to misconfigurations or other things? And you know, the past 10 years has largely been about automating that and establishing best practices for doing that. But now, you know, we're saying that security should have always been part of that, but now it's become even more critical, especially in light of, you know, these supply chain attacks. The pipeline for applications needs to be secured as well, and that's something that simply requires collaboration in order to do that. It can't be just security's responsibility, and it can't be wholly offloaded to the development team. So there is this separation of concerns. The way we look at it is the security organization really needs to be responsible for the secrets lifecycle. In other words, the passwords, often cases, the onboarding of those accounts into the vault and the vaulting of those secrets, the ongoing rotation of those secrets, password complexity enforcement. Those are the kind of things that the security organization needs to be responsible for. But a large part of at least some of that, the responsibilities can be delegated to the project teams, and really should be, so that the project teams can be as autonomous as possible. And so in many cases, you can delegate to the project teams the creation of identities, the granting of permissions to identities. The real goal is that developers don't really have to know a lot about this. They can write their applications, and all they really need to know is, what's the name of my secret, and how do I get it? How does my application retrieve it? How do I code that? So we're not going to dig into that. A lot of my demos go into how do we authenticate in various cloud platforms, and OpenShift, Kubernetes, Jenkins, Tower. We're not going to focus on that. We've done a lot of webinars that do that. What I'm going to focus on today is the workflow around how does an application developer come to get access to a secret? And what is that workflow in light of what we just talked about in terms of controls? Here's an example, and I took this from one of our customers. It's actually a big Red Hat customer that's been in production with CyberArk and CyberArk's Conjur in their OpenShift clusters for going on 3 years now. And this is a workflow that they built for themselves. So the horizontal swim lanes are different roles. So at the top, we've got the project team. They fill out their access request in ServiceNow, saying, you know, we're in this project. Here's our billing code. We need access to this and this resource. That ticket goes through a couple of approval gates, one by the project owner, one by someone in InfoSec. And then it drops into an automated provisioning process that creates the safe for the project, creates the accounts for the project. And remember, those accounts are the things that actually grant access. They hold the credentials that the application can use to access whatever it is they need access to. They provision the permissions for the application, create the identity for the application, and the developer gets that back in a nice email saying, here's the identity that your application can use, and it has access to these secrets. So that's what we would call a security-owned workflow. Basically, the project team isn't doing anything. Nothing's really been delegated to the project team. This is all fulfilled by a workflow in the security organization. That works for some folks. It doesn't work so much for others. We've implemented a more 50-50 collaboration model where the safe and the accounts are created by the security workflow, and the creation of identities and permissions can be delegated to the project team. We've also seen where all the security team does is create the safe and then give the project admin the ability to create their own accounts in the safe and then create their identities and permissions. So those three models, one's wholly owned by security, one's 50-50, and then one puts the onus of work on the project teams. Again, no one organization. Sometimes the variation is from dev team to dev team. So we need to be flexible, but we need to have frameworks in which we can suggest, here's an operating model that we think might work for you, and then work with those project teams in delivering that model. One last thought before we jump into the demo, and this gets again at that scale. I was just talking to one of our professional services guys who's built several of these implementations for our customers. And he was saying that there was a term that they were using as they need to get to business as usual for for access requests. And what that means is, again, going back to that scale where if every access request has to be reviewed by the change review board, nothing's going to happen. Everything's going to get held up in the approval process. So you need to be able to distinguish between low risk and high risk sorts of requests. And for those low risk requests, you can auto approve those. The thing is, you're still going to have those forensics gathered. The approval, even though it's automated, is still recorded. The provisioning process is still logged. The access is still tracked, but the developer isn't having to wait for their access. And the closer you get to production, the more you're going to need to scrutinize those requests. So typically a new access request in production is going to need full change advisory board review. And so where that line falls between a general business as usual, auto approved, auto provisioned workflow, and the workflows that need more scrutiny and need more oversight, that again varies per application, per request, per organization. But it gives you some things to think about in terms of what makes sense in your organization, what workflows would actually solve both your productivity requirements as well as your security requirements. And that's always the thing that we're trying to balance here. So enough slides. Let's jump into a demo real quick. And again, any questions, you can just log in the chat window. I am going to share my screen. Let me just do a quick audio check. And Dave, if you could come off mute and just give me a high five, or am I coming through loud and clear?
High five or fist bump, whatever you prefer.
All right, very good. Just always like to make sure I'm not talking to myself here. So
yeah, all good.
So here we're going to share my screen. And again, Dave, I'm going to watch the presenter thing. So if we have any more network difficulty, just hopefully that'll be a channel that you can give me a flag. So everybody should be seeing my screen now. That with the Conjure UI here, I'm going to refresh this and relog in, so I don't have to do that here in a minute. So what we're looking at is a UI. Conjure is a secrets management solution that you can think of as an adjunct to the core CyberArk Vault. So the core CyberArk Vault typically governs human access to privileged resources. So we're all about sort of root level access, sysadmin access, controlling that access. Conjure is a way of distributing secrets from safes in the core vault and giving access to applications running in things like OpenShift or Kubernetes. So this demo, what we're going to do is show a Kubernetes identity that currently has access to a safe called Pet Clinic Test. So the somewhat contrived demo scenario here is I'm a test developer. I'm testing the appointment making capabilities of this pet clinic application where we're trying to track the COVID vaccination status of pet owners. And I'm in my test environment, it's just not working right. And so what I want to do is figure out why that's the case. What is it that's broken, that's not working? So what I can do is I can generate my YAML. Dave's going to recognize this. This is actually derived from a a workshop that we built for the Red Hat partner demo system for OpenShift. So this has been downsized to Docker desktop Kubernetes, but it is very much, Dave will know what we're doing here. So I've generated the YAML for my application, and so we can see the manifest, the policy. This policy is what actually governs the application's identity, and what, to some degree, what it has access to. Certainly its ability to authenticate here. We're not going to get into that in great detail, but we're going to look at this config map here. This config map is the thing where my application knows what secrets to retrieve from the Conjure service. So you can see that the names here correspond to the names over here. So this, we're seeing that this application has read access to the MySQL database address, password, and username for the pet clinic test database. So that config map is going to be loaded as environment variables in my application. I have to actually deploy the application. And now, if we exec into the application, I'm in the application container. If I look in my environment and grep the things beginning with 3D underbar, then we can see those are here. So this is just the names of my secrets that this script can actually use, authenticate to Conjure and retrieve those secrets and connect to the database. So here we see I've connected to the database as test user 1. I've pulled the password that's here. If we go over here and look at what the password is, I'm logged in as the admin user, so I can see everything here. So it's pulled that secret. So it used our Kubernetes authentication, which is kind of what we get into in the workshop, to authenticate this pod and retrieve these secrets that it has access to. You can see that this is running local to the cluster. We've logged into the Pet Clinic database, and I could say describe the owners table here. And the owners table doesn't say anything about COVID here. And so my suspicion as a test developer is there's a schema change that didn't get promoted from dev to test. A classic scenario, something didn't get, in our handoff to test, didn't get promoted. So what I'd like to do is get access to the Pet Clinic dev database and just test my theory. Would this application work correctly if I connect it to the database? That, or can I just go look at the database and see if my suspicion is correct? So what I'm going to do is fill out an access request. Now, this is just a kind of a toy front end. Normally this would be something like ServiceNow, and I'm going to say for my user 1 project, I want access to the Pet Clinic dev safe. That safe holds the account for the Pet Clinic dev database. Requester is me. I'm requesting access in the dev environment, and I want to make that for example sidecar. This is, so what that does is submit that access request, and will, if the demo gods are with me, actually provision it, and it looks like it did. So this is the developer now. The developer's here. The developer's saying, where are my secrets? Where are my secrets? If I go back and look at my access now for that, we see now that it has access to the Pet Clinic dev secrets. If we look here at this password or the username, we can see that it's got a different username. I was test user 1, now it's Java user 1. What I can do is exit out of here, and just by way of example, this is the role of the security admin. So that separation of concerns. The developer made the request. Now here's the security admin. Here's my the UI for the vault. And here's where I can look at the access requests. You see here we can see unapproved access requests, those that have been approved but not provisioned. We didn't have to go through any approval cycles here. This was auto-approved and auto-provisioned because it was a low-risk request. This is a test developer requesting access to a dev database, presumably part of their own project here. So we went ahead and auto-provisioned that. We have the option of revoking that, and we'll do that here in a minute. We would have had the option of rejecting the request at either one of these stages. And really what we're just showing here is the kind of control that you get. Ultimately, what these processes are doing is just orchestrating REST calls to our vault and to Conjure to provision this access. So what that means now is I can go change my config map and change the variables that I'm retrieving here. So instead of test, I'm going to now change this to dev. And just change the name of the variables that I'm retrieving, and basically redirect my application, redeploy my application to that new config map. We exec into the application. We're in the application now, and we grep for things beginning with DB underbar. DB underbar. We see now, didn't pick up my config. Did I not redeploy? Live demo, folks. So I'm going to delete that. I think I didn't delete my app. I didn't redeploy it. Let's try that again. Back in here. Now, if I go, I think it's beginning with DB underbar, it should be for a dev. So I just didn't redeploy my app and pick up the change in the config map. But now, I didn't change anything else in the app. I just changed the config map, immutable containers, that's what we're all about. But now, when I run that same script, it's going to connect to the database. It's actually running up in Azure, and we're using that Java user username that we saw, the password. It's a completely different database. And if we do the describe owners here, then we can see, well, here's that COVID vaccinated field that we were looking for in test. It didn't get promoted out of dev. I can fill out my bug report and say, look, you guys need to promote schema changes along with the code, and I can get on with my work. So as a test developer, I'm more or less done with that flow. But let's take a for instance, and let me show you one more thing before we do that. So I can see this here, have the potential to reject this here, but we can also start looking forward to things like an auditor saying, what does the user one project have access to? And so we see here that user one has an identity called app example sidecar, has access to a database called Pet Clinic as Java user one. So we've been working with another one of our partners, SailPoint, to start saying, how can we feed this information into SailPoint? So that SailPoint, which its role really is as that sort of governance interface, or the thing that people really look at for identity governance. How can we feed this information so that an application like SailPoint can start tracking application identities and the application and the access that they're getting indirectly through the CyberArk vault? We think there's huge potential in that. And this is just a reading on. I don't have any capabilities here other than reviewing what has access to what. And that will be updated as we deprovision things. But let's do one other thing here while we're at it. Let me rerun my access request form here, and I'm going to request access to production. And so I can say user one, I want the Pet Clinic prod database. That's with me. I'm going to do this for prod. Same identity in my project. So I submit that. Now if we go over here and look at our access requests, that's just an unapproved access request. And here I can just say, yeah, no, that's not appropriate. This is a test environment accessing production. We don't want to do that. But even if we do that, we have, at least in this workflow, and again, I want to be crystal clear. This is just a hypothetical workflow that we can enable. Again, this is going to vary per organization. But in any case, we can reject this here. If somehow we rubber stamp this, or fatigue approval sets in, we disapprove whatever comes in, we have the opportunity to reject this here. But even if it gets provisioned, and that access gets provisioned, then we have the opportunity to also review that in an audit perspective. So we can say, okay, app example sidecar not only has access to the dev environment, but somehow it got access to the prod environment. And we can say, look, that needs to be rejected right away. So we can revoke that access. The access goes away. All is good over here. And now it's just got access to the dev environment. And then if we deprovision that, the application then loses the access that it was so quickly granted. So if we go back into the application and try and access that database now, we no longer have access to it. And so our connection fails. So that's just kind of a quick tour of, what we're actively delivering solutions like this to our customers. I'm going to jump to the chat window and see what we've got for the Q&A here. And then see if we've got any questions. But hopefully this starts to give you guys, let's see. Okay, so Rama, how would it solve a secret zero problem? Excellent question. That's typically what we go into in our demos here. The short answer is where we have a platform like Kubernetes, OpenShift, Azure, AWS, GCP, we can predefine the identity in terms of attributes that can be validated with that platform. And so that's the short answer to that question, is we're validating attributes that have been predefined and associated with that identity. Just as a case in point, if we look at my identity over here that I was accessing this as, we can see the annotations here of this application has to be in this namespace. It has to be running as this service account. And these are a couple of the attributes that are predefined, as well as the current pod, the current name, the current pod name, current IP address. When the application goes to authenticate, those are submitted to the Conjure service, and it will validate those attributes with the Kubernetes service. And if all those attributes check out and are true, then it will authenticate. More detail than you might have been looking for, but that is a shorthand answer to how we do authentication, and it works in Kubernetes. It basically works anywhere we have a platform that we can validate, that we can trust to know what's actually running in it, and for which we can attach annotations to an identity that can be validated with that platform. So how does secret management get injected into the pipeline? There's various ways of doing that. So the example that I showed here was with just using a REST API. If we cat the script out that I was running here, we can see that this was just using our REST API to pick up the token that's provided by our authenticator, and then use that token in the REST calls to retrieve the secrets. There are other ways of doing that. We can push secrets to Kubernetes secrets, for example. So we address some of the shortcomings in Kubernetes secrets, but you can still use native Kubernetes secrets there. Let's see, is there a way to see what applications in the cluster are using environment variables?
I can comment on this one, Jody.
Oh yeah, please.
Yeah, so this would go towards more of a runtime analysis type tool. Some of you are familiar with one of Red Hat's recent acquisitions. StackRox is one of those tools. We're calling it Advanced Cluster Security now. It's part of OpenShift Platform Plus. And in that feature, in that product, we've got a policy that will fire off if it detects if any environment variables are using secrets. And I'm sure our other partners as well in the runtime analysis space do similar things. So that can sort of notify you that, hey, you're using secrets in this application. And then obviously you'd go to CyberArk to understand the implementation details of how to properly manage those secrets.
There was one question that I saw. Let me see if I can grab it here. How much of a barrier does this create if it's not configured properly? And then the example given was a dev team needs to read in prod to gain access to the containers and the DB and queues to solve a production issue.
I think that's one, and this is exactly the kind of scenarios that we like to hear about. I was having a conversation like this with one of our customers just yesterday about an escalation. So you have an escalation, you need to grant temporary access to the prod environment. That's exactly what we're really modeling here. I realize I'm still sharing the screen. I'm going to stop sharing. But the idea is that if you can provision access quickly with sufficient oversight, then for those non-business as usual requests, which is, I think, what this would be an example of. A dev team needs temporary access to the prod environment, and it's their application. It's not the person. It's the actual application needs access to a prod resource. Then that could be flagged as, fire drill, whatever. Put a flame symbol next to it or something. It gets the right approval oversight, but can also get accelerated approvals and provisioned. And then equally, you could set a timer on it. I mean, you could do something as easy as just setting that this is going to expire after an hour, unless it's reapproved, and do something like that. So that's what we're trying to not. We're still trying to enable productivity. We want development teams to be able to get their jobs done, and emulate a lot of what the cloud platforms have provided. So most dev teams have their own account in the corporate cloud. I mean, I'm speaking, about my experience. I've got a corporate account in Azure and in AWS, and I can, within reason, provision whatever I want to in that environment. When I make my request, for a new EC2 instance, then I can see the status of it. It's spinning up. It's going through status checks. It's now ready, and so what this demo didn't show was a lot of that kind of feedback back to the developer, other than now I have my secrets. So that's the kind of thing that we want to enable. We want to take that sort of self-service automation that is bounded, within reason, but gives the developers the ability to do their day jobs without a whole lot of having to call up the security team to do something.
Right.
But the scenario you painted would be an exceptional condition that could still fall into this framework. It's not something that couldn't be supported.
Yeah. And I was interested to know, because you were talking a lot about developer experience, and I was just wondering if there were any specific standards or best practices to follow around developer experience, or is that kind of like a team by team, developer by developer thing?
I think it's, and this is where, I'm sorry, Dave, were you going to say something?
No, I was going to let you take it, and then I can provide some color on the DevOps piece. No,
it's. I think it varies on per team. I mean, really, and Dave as a ex-developer, me as an ex-developer. When you're in the zone, you don't want to get out of your zone. You don't want to have to wait on something. You're getting something done, and if there's something that you don't have currently, Stack Overflow saves me every time. I'm so if I don't have internet access and I don't have Stack Overflow, I'm not going to be very productive.
Right.
And so that's kind of what we don't want to put any obstacles in the name of security while still being secure. And that's where the paradox lies.
Yeah, and I would just add from a DevSecOps perspective, two things that come to mind are train your developers, as I mentioned, just on core security concepts, like what is the OWASP top 10? Get them to understand those things. That'll give developers the ability just to be cognizant of, as they're typing, is this secure or not? And then try to add tools to what they're already doing that are security based. The one I think about most is in IDE. There's this tool called Dependency Analytics. It's actually an open source one contributed by Red Hat, but that will look at all the dependencies that you're bringing in and let you know if there's any vulnerabilities. So simple things like that, I think, are best practices. Make sure developers sort in the shift left mantra, get those tools, but also train them.
Yeah. All right. Well, thank you very much. I think that's probably about all we've got time for as far as questions. Folks, if you send questions in that we did not get to, rest assured we're going to round all those up and send them over to Dave and Jody. They will be able to follow up with you offline. Just as a reminder, again, the session has been recorded. So if you missed any or all of it, you'll be able to go back and watch it again. We will send an email with instructions for accessing the webinar on demand, or you can always visit us at devops.com/webinars. It will be there for you as well. All right, so now the moment we have all been waiting for, we're going to choose our Amazon gift card winners. And our first winner this afternoon is Jim S. Congratulations to Jim. Our next winner is Wayne L. Congratulations, Wayne. Ken K. is our next winner. Congratulations to Ken. And finally, Josh T. Congratulations to all of our Amazon gift card winners. We will be sending you an email with instructions for claiming your gift card. So keep an eye on your inbox for that. If you do not see it come through there, please check your spam folders. All right, folks. Well, to Dave and Jody, thank you so much again for joining us today. To the audience, thanks for tuning in. We always appreciate seeing you, and hope to see you again soon at another DevOps.com webinar. I am Sharon Florentine, signing off.